Today I'm going to try and explain the physics behind a climbing fall, namely the fall factor and the impact force. So in climbing, right, you have the belayer who's at the bottom holding the rope, you have your climber who's bringing the rope up, and you have your protection. The protection looks like this. Basically, the rope is being pushed into these metal carabiners, and that's what's catching you. So because of that, since you're often above your protection, the height you fall is actually your distance from the protection to you, times 2, because you're gonna go all the way down, double that height. The rope's going down with you, and you're landing 3 meters below your protection. So you would have this would be a 6 meter fall. So in fall factor, you're taking the distance fallen over the rope in the system. If you look at this example, there's 12 meters of rope, and you're taking a 6 meter fall, so you get a fall factor of 0.5. So why does that matter? Well, for instance, you could be falling 10 feet if your distance fallen is 10 feet, and there's 20 meters, or 10 meters and 20 meters of rope in the system, you're gonna have the same severity of a fall as this, right? Because you're still getting a factor 0.5 fall. So the reason that is that if you imagine that you're on a fence and you jump down, you're gonna have a bunch of velocity, you're gonna have a ton of speed, and you're gonna have to decelerate the moment you hit concrete. And the moment you hit that concrete, all of that, there's a bunch of force being exerted to keep you from going through the concrete, the normal force, right? And so you can do these calculations to find the amount, your velocity, and translate that into the energy that you're carrying in kinetic energy, right? Kinetic energy. But let's say you add a cushion. Well, suddenly some of your energy, your potential energy, is going both into your kinetic energy and into crushing that pillow or the cushion, right? So in rope climbing, you're not falling on to anything in particular, right? You're falling onto just midair, but that rope is going to provide some of that cushioning effect because it's a dynamic rope that stretches kind of like a rubber band. So because of that, some of those kilonewtons of energy is going into the rubber band. So for instance, in a fall that has a fall factor of 0.3 with these weights of the belayer and the climber is experiencing 2.5 kilonewtons of impact force, while the rest is going into the stretch of the rope, right? And so after that, the belayer is also getting some impact force, and then the anchor is taking the sum of the two. For comparison, in the NFL, your pound force is roughly 1,600, so that's 7,000 newtons or 7 kilonewtons. So it's less than an NFL tackle. And that's all because the rope is taking some of that kinetic energy.